So we're gonna just do because I work at the university a little bit. I study old trees, and so we're gonna talk a little. We have to talk about cells and junk. I'm sorry, but I'm not because you need to know this stuff.
Ryan, before you go on, tell everybody what you do, company,
Oh,
and
I
all
can't
that.
talk too much about this because I'll get distracted. But my company, so I have two jobs, right? I work for myself, and then I work for Mr. Murphy over there. Um, my company specializes in tree and woodlot preservation work. So we come in when oak wilt comes through, or you get diseases, or a tornado or something. We'll make it safe. We'll take care of the insect disease issue, and then I turn it into something cool. And so that's kind of the full circle there. And then at the U, I study old trees, and so we look at decay profiles and do crown modeling, and it gets really complicated. Um, but so I got my fingers in the pot, the actual work, all sides of the actual work. We do small scale logging too, and I know how to study and measure and math everything out. And so that's why I'm here talking to you today, is because I kind of speak everyone's languages and I see how it all interacts. Good. You want to hear more? Josh will tell you about it. So we're gonna skip over most of the basics of the physiology, and we're gonna focus on just a couple of the most important for sawing lumber things. So pore size. So did the tree grow really, really fast for a couple years in a row? You're gonna have really big pores. So that's like the size of the vascular tissues that are big straws that grow up and down the wood. If they're really big and they're dry, now you got a bunch of hollow tubes everywhere. And so that's why some species weigh like nothing, is because they're just full of hollow tubes. And they'll reabsorb moisture more readily and all sorts of weird stuff. They're also weaker because they're less proportion of solid wood material and they're more air. So some of these species you can think of would be like cottonwood when it's dry, um, willow, some aspen. If it grows super fast, it's probably in that category. So you just need to be aware of that. Sapwood versus heartwood has a huge difference in decay resistance as well as structural stability. Heartwood is kind of your premium stuff if the tree forms heartwood. Not all trees form heartwood. Some form this thing called ripewood, which is basically heartwood, but it's not. It's just there's like a chemical difference, but it looks the same. They'll be discolored, and it'll have like ash is one of these. You can see ash logs that are perfectly honey colored on the end, and you'll see some that have like this walnut color. That walnut color is the ripewood. I think it's more stable, personally, but to each their own. You'll have your own experience. And then every species has its own decay resistance. And this is linked to these two a lot, the chemical defenses and stuff and pore size. But not always the same. Like cedar grows super fast, big pore size, extremely decay resistant. So it kind of defies the rest of the rules. Where like white oak and bur oak grow slow, very defined heartwood, very decay resistant, but not as decay resistant as cedar. So you'll see this chart later. But that's why those three are important. But also, you have the tree. Everyone's familiar with this. You look at the end of the cut and you can see the growth rings. How fast is it growing? How old is it? Did it have like a stressful moment in its life at some point? And so they tell you a lot. But also, from our perspective as sawyers, they might tell you where the reaction forces and the weird stuff are in the log. If the pith or the center is off to the side, that tree might have been growing out of lean. And so it's got all this like force built in pushing up. And it's also got force pulling up. So if you cut that log this way, what are those boards going to do? They're going to bend on you. And if you cut it this way, what are they going to do? Bend on you. And so you can use the growth ring location to tell you a little bit what that piece of wood's going to do. I wouldn't say throw it away if it's off to the side, but you need to be aware that you might have to do some straightening later. There's in the log grading for the U.S. Forest Service, there's actually a component for where the pith is, so it'll calculate out that degrade. All right, we talked about that. So wood is cool. It's strong in every dimension. It pulls itself together and it pushes itself apart in every direction. And so straight, clean wood, like the right side there, perfect grain, right? but it's actually more flexible than a spot where there's branch unions and some crazy reaction forces, because that wood is stiffer. And so now it's actually stiffer and harder. And so this is actually technically stronger in like a bending resistance perspective than that is, even though we think of that as stronger. So we can talk about that later. We talked about this a little bit. The heartwood is more resistant. Who's seen old dead bur oak on the ground? Big logs? Yeah, right? You know what it looks like? This is bur oak. That's sapwood. In this case, it's cream colored. I can pick it apart with my fingernail. It's rotting faster than this heartwood that's impenetrably hard and stiff. And so that's a perfect example of the decay resistance. The heartwood will last forever, but the sapwood's gone. So if you make a house out of sapwood, what's going to happen to it? You're going to make another house. So don't do that. Not all species are the same. Like if they don't form true heartwood, you might have a different thing going on with that species. So you can use the sapwood. In some cases, the sapwood's the premium cut on that log, depending on your species. Okay, this is really cool. I found this the other day, and I had never seen it before. This was a study done in Minnesota, but by some Wisconsinites. And so they looked at fence posts, like commercially available fence posts, where they mill them down into a perfect cylinder, and they put them in the ground, and then calculated roughly how long they land, or they last, you know? And so what you know, red cedar won, redwood they brought in second, but there's a huge caveat. You have to do a bunch of stuff to it. You have to treat it, yada, yada. Cedar is untreated. And then you go down the list, and you'll figure out who's the most resistant or not. But they had to leave a lot of variability in there. And this is the reason why, I think. The direction you put that post in the ground relative to how it grew is super important. Because wood is just xylem tissue. Xylem pulls water and resources up. It does not go back down. And trees, the way they pump water, they have like all these little, they like pump it up there. And with like, you know, they move in the wind that flexes them. And it's too complicated for this. But there's basically check valves. And so it goes up, can't go back down. And so if you put it with the bottom in the ground, decay organisms and everybody can crawl up those tissues and work their way into the post, rot your post out faster. You flip it up the other way, there's check valves in place. So it's a lot harder for them to invade that wood, and so it'll last longer. But when you have a perfect cylinder milled at a processing facility, how do you know which side's up and down? It's a lot harder to figure out. And so that's where I think the variability and the decay resistance came from. It's like they put one post in the right way, they put the other post in the other way. And anywho, so if you're putting posts in the ground, put them upside down. All right. Physiological impact of drying. Pore size. If there's more water in the tube, but it's a bigger tube and it dries, it's going to shrink. Because trees they're hydraulic, so the water is actually a structural member holding the thing together and pushing it apart. So as you take that water out, it's not holding itself together anymore. We'll see more on this later. The bigger the pore, the more likely they are to reabsorb moisture. Some species defy that fact, and they'll just pull moisture right out of the air. Some will never pull it back in again. And so you got to know some stuff there. Certain species, specifically the pine group and some spruces, they'll be really pitchy when they're fresh cut, and they'll just keep oozing out. And the sun will heat it up for a day, and then it'll like ooze out more pitch, and it'll just keep coming, and it'll never end. And then you saw it into some boards and try to sand it, and then your sanding paper or whatever it is will get all gummed up from that pitch. Or you put it, or it's your mantelpiece over your hearth, and it gets hot with the fire. It's just going to be raining pitch down, you know. Or you make a cool little thing in your car to go on your above your steering wheel to put your snacks in or something, and it's not heat treated. You're going to have pitch all over your whole car, which smells great. I do this on purpose in my work truck. Smells better than sweat and farts. So it's okay. Just don't let it go into anywhere it's not supposed to. There's the secret. But you can do something about that for how you process the wood when it's drying. And then wood shrinks. It doesn't seem like it won't, but it will. And it shrinks in kind of a fun way. So every species has a different characteristic. Some are really furry and hairy, like cottonwood. You try to sand it, basically always furry, unless you're really lucky. And then fasteners, some wood's really brittle. So you try to use a nail gun and put nails through dry ash, it will split on you. It's very nice, very fun. So you have to pre-drill all your holes in some species. Some species like pine and spruce and fir, which is, you can imagine why we use those in construction, you can pound nails through there all day, won't crack. So, you know, that's something to keep in mind, especially if you're building pallets. You want to choose your species carefully. Some accept paint, some don't. Some just keep pulling the paint in. You think you painted it. You said, I painted it. There's no paint. Where'd it go? Some species just absorb the stuff. And then something that's a lot more popular these days is like the Shushugiban or the Yakisugi, which is the traditional, that's the actual name if you speak Japanese. Does anyone speak Japanese? Close, right? Well, anyway, so I asked some Japanese people, and what's Shisugiban mean? And they said, I don't know, it's like kind of, sort of burnt, maybe, but it's like not an actual term. But yakisugi means burnt wood, and so that's the proper. If you're going to refer to it, I guess that's what I would like you to use. Anyways, you just burn the heck out of the wood, and it creates a nice coating, and it was beautiful. I'll show you later. If you want to see some and touch some, there's some right here on the bottom. That's ash.